So hi everyone, welcome to this month's webinar, which was like almost 2 months since last webinar, but things happen. Today we're going to be talking about AI because we haven't done this in a while. This is actually a second in a series of 3 webinars about testing products that include AI. Last one was September. You can watch it on the YouTube channel at Testing Gil. What we did last time was talk about techniques and stuff like that. Today we're going to dive deeper and look at examples of how to do things in real applications, as much as a real application that I can show within an hour of a webinar. But let's try to do this. So, hi, that's me. I'm Gil, and I'm a trainer and a consultant about all things that help make software better, and sort of looking at AI because it somehow makes software better. That includes that I work with developers and testers who struggle with software and challenge and wrestle with it and so on. Okay, enough dramatic stuff. If you need my help, you know where to find me. You already found me. Yeah, so that's enough. That's enough about me. Let's start talking about this. But before that, I have a poll. We talked last time about golden data sets, definition of good. And this is a poll about where you are at this point. You're using golden data set or something like this, a formal thing, something informal, something more subjective, something that you can look at and say, this looks fine to me, but somebody will look at it and say, that completely, I wouldn't agree with you. Let's wrestle for it. Oh, you don't. You're not there yet completely, and you're just wrestling yourself. Half of you is not dealing with it yet systematically, which means either one of two things. You don't have AI in your products, or you think you don't have AI in your products, or you're not doing it systematically yet. Yeah, not a lot of people are doing this like in a systematic way. We can see that. It's nice to know where we are. Thank you for your answer. Okay, so what did we do last time? I was this old last time. And like I said, it was a while ago. What we talked about in the introduction to this series really is what are the problems that or challenges that we have when we have AI in our products, in deterministic results, the ability to say, is this good enough, not good enough? How do we ascertain if something is good? What's our job as testers, and what has become of our skill set now that we use AI, and try to look at different techniques like the principles, like the testability. We talked about that. I'm going to show examples today as well, how we prepare our code to be tested and what it actually means for testing, which is really what we want to know. And we talked about sanity checks and diversity checks. I'm going to show them as well today. And we talked about golden data set like the one I asked. And we also talked about something that we're not going to expand on today, the AI judge, was we actually delegate our decisions to a powerful being more than the regular one. So we talked about these as techniques and principles, but how do they fit together? So this is what we're going to actually talk about today, because when we're trying to see like, okay, we're in it for the long haul. We're building a product. It's not just like one prompt. We may be building an agent, which means that there's going to be a couple of calls. And that means that for each call, we need to take it and do something with it and maybe prepare it for the next one. Or maybe the application itself is like we're calling a kind of API for a model, get something and do something with it and present it to the user. How do we know that it's good, that it's working? So the questions like keep repeating themselves, but the more we think about it, we understand that it's not just techniques. We need to think about it in a more systematic way. And we did that like before AI was a thing, like 3 years ago. Everyone had some kind of methodology of how they test products. It doesn't make sense that we don't need that anymore. We just need a better one or improved one or something that includes the chaos inside it. And we just need something to build. And luckily for you, I have one. So this is something that I've been using, and I'll take you through the stages here. And it looks like a funnel because it's sort of a funnel. I try to visualize it in some way. And by the way, this is not the end of the funnel, but this is something that I'm going to show you today. We'll talk about that at the end. But there are kind of stages here. We talked about planning and designing, which is, of course, it's there. We need to do planning and designing. Usually planning is what we're going to test, design how we're going to test it. And I showed you a couple of things last time. I'm going to show today a couple of techniques that like just a pinch of something, but the more we need to be confident about our testing, we need to invest more, even more than we did before AI. It makes sense. Then there's checking our logic. The developers are writing code. And if you think about it, even before AI, they wrote code as well. And even then, in those old days, the code was like this of something that actually ran, because they ran servers and integration stuff and proxies and stuff, and like a whole lot of things that they didn't write. So the idea behind developer test then was that at least we know that these things are working, that the things that we write. Same goes here, because we're calling to AI models. It is a black hole. Something comes out of the black hole, but at least we need to know what our code is doing and that it is working, because if we look at the entire blob of things and something goes wrong, at least we need to know that these bits are still working. So part two, check the logic, obviously. And then we're moving into like the real integration part. The integration part is like when we call the model and something happens and we get a response back and we do something with it. So we're dropping into the funnel and therefore some things in there don't make sense. And don't make sense means we get a response that we can't continue working with it. It could be like in my agent example, which I'm going to get back to, is I got a response that I can't work with. It's an empty response. I'll show an example when it actually happens. I can't do anything with it. I can't show it to the user, or I can't feed it to the next call to the model because it's empty. Can't do anything with that. Things that we cannot accept. And this is like the original definition of sanity checks or smoke tests that we use. If these things are not passing to our quality benchmark, that means that we can't do further testing. We're not interested in doing further testing. This is not working. And then there's the manual quality check. And I mentioned last time, I'll give you a very short example of golden data sets. I'm going to dive deeper in that. And the further steps later, which is kind of maybe automating that, and further steps as well, which I'm not going to cover today. We'll do that in the next webinar, but let's leave that to the end. So what are we testing? An agent. I know. So our agent is the API analysis agent. It is, let me show you the code. I'm going to show this in Python. I'm going to use Gemini as the model, but everything that we're going to talk about, especially the manual stuff, can work with any languages or models. It doesn't really matter, but what really is important is the principles behind it. So what is our agent doing, basically? So our agent, we're starting off, has three parts. The agent code, it has, this is like a regular class in Python. This is our logic, really. And where is it? Inside it here, it calls the model. So I'm using the Gemini library to call it. So I'll show you in a minute what it actually does. It has a controller. So a regular client will call the controller with an API post, we generate plan. So we send some kind of JSON inside it as the body, and it asks for a plan. How does it ask for a plan? Our agent here is configured through the constructor with a key and a model. In the constructor, in the initializer, it does some kind of validation. The keys are okay and stuff like that. It has the entry point of generate plan for endpoint, gets the endpoint passed for it from the outside. It then loads a prompt template. So in my case, I'm running the agent locally. You can see it here. And so, the prompt is an external thing, which is important. If I run it in the cloud, I will probably load this from a bucket somewhere in storage. The idea is that it loads the template of the prompt, and you can see that the prompt says, you're an expert senior QA automation engineer. Based on the endpoint information, give me a generated comprehensive test plan in Magda. So it gets a method and a path and descriptions and asks for API. So the plan to include API explanation, happy path, unhappy path, and edge cases. All kinds of terms that I dislike, but most people use. And a description, so a plan has to do like this. Our agent loads this prompt template, embeds it. This is the create full template function. Embeds the method information that I pass it inside it and returns it. It then calls the model here with a full prompt with embedded data and get a response. Here's the some code that looks at what we got back. If it's empty or very small, it says the AI model return an empty plan. If it's return the plan, it formats it. It's not a function here, basically just doing some kind of editing, but it will suffice for our purpose today, and then returns it to the controller, which returns the body of the response. So that's what we have. This is what we're testing. Obviously, this can be a lot more complex, but for our purpose today, I think it serves what we need. Okay, so let's start from the top. Remember, the top one was plan and design, so we need a plan. So first of all, I said before, what are our skills, our testers? Everything that we had until now is still useful. That includes planning and design. Planning means that what are we going to test? Design is how we're going to test it. And we're the experts, and we can use AI to help us with a plan for that as well. So why not? I have an example here of a prompt that I used for this purpose of this agent. And it's a bit interesting to see that what I did, I actually specified how this thing is built. Now, if you're coming from a black box point of view, say, well, what does it matter how it's built? Now, it turns out if you want to know what I wanted to know, which is if my bits of code are working well, like where's the separation between the model and my code? The more I write or give ideas of how the structure of the application is, I can get more interesting ideas of how to test it. I usually think that big proponent of knowing how the system is built, because that means I can understand where we need to mock stuff, simulate stuff, inject stuff. Talk about that in a minute. The more I know, I can tweak the system and shake it in different directions to see what comes out. Specifically in our case, and we'll get to that in a second with the developer tests, we talked about last time that it's very important to check our bits of code. And therefore, I need to know where my bits of code are. So yes, I can use AI. I don't have to. I can use developers as well to tell me where is my bits of code or their bits of code and what they're sending out. And this information is very important. So if I do this, this is an example. This is my thing. Like this is the class with the logic. It loads the text file from the outside. The controller has an API post. And I asked for different types of tests, controller API tests, agent unit tests, and so on. I didn't even said go generate it. But you can get a decent test plan. And this is like I asked for different types of tests, and therefore I can implied I want design in some way. So test design tells me that how am I going to test it? Well, I can test what I'm going to show you with the developer test, things that are working in some way without calling the model. We'll get to that in a minute. Again, if I didn't do that, if I didn't specify do this separation or that the prompt gets injected in some way, either the developers wouldn't tell me how things are working if I didn't ask them, or the AI would know to suggest things. So think about what you're trying to do. We talked about the testing layers last time, and this is, it turns out I'm going to use like, this is my code in my agent and controller, my code, my logic, really. So this is a scaffolding. This is the logic that I want to make sure that is working. There's the plumbing code, which kind of wraps around the call to the model, and we might want to check that it's okay. And then there's the whole experience of calling the whole system here. And we want to make sure that the experience from the user's point of view or the client, whatever client or user is experiencing, is to our satisfaction. Okay, so yeah, we did it. We did the planning. Don't need to talk about much. We want to do some testing. So the first thing I'm going to talk about is developer tests. And I don't know how many developers we have here today or watching. We're talking about collaboration. Developers and testers need to work together. Now, this is not something that is new. And I preach about that for, I think, 25 years. I talked about like having this kind of conversation about how the system is built so I can test it better. But it doesn't have to be just like that. Remember that I told you that the prompt sits in a separate file, right? It doesn't have to. It could be sitting hard-coded into the pieces of code, in the bits of code. But if it's sitting in there, I have no ability to tweak it. And this is something that I'd like to do, to see that if I tweak the prompt, what kind of responses I get. So this kind of, we call it seam. This kind of seam in the system doesn't happen by chance. It needs to be put in there or needs to be requested to be put in there by someone. Someone thinks like, how am I going to test it? How am I going to tweak it? How am I going to change it without deployment? This is similar, for example, for putting values in configuration files. Why do we have configuration files? Well, we don't want to go through the compilation and build again. We just want to tweak something. And we still want to do these kind of things. But in order to do that, we need to think about, well, I'm going to have a need somewhere in the future that I want to tweak it. And therefore, I need to put something externally, the prompt. Or I did something here that you may have not seen or thought that is important. So I broke down the big giant method that could have done everything into smaller things like create full prompt, which takes the template and returns it with the embedded data. Or format the plan, which takes the response from the model and formats it. So that's the logic. And if I write the code this way, this is Python, so I can call private method, but it doesn't really matter. I can check these pieces of code. This one without the model. This one without actually, no, don't move stuff. This one without loading it from the file. I can just check the template here as a parameter. So this allows me to test the code. I need to write the code in a certain way. We call it testable code. Sometimes we call it clean code, which kind of coalesces with the testable code. When we needed to write code in a certain way. If you go back to what I said like a few minutes ago, if you're coming from a black box point of view, like I don't care how it's written, you might get stumped. If you don't know how the code is written or you don't have access to it, you can't write tests for it. You have to write stuff for the entire system. And if something goes wrong inside it, you'll need to debug the entire thing. So cutting down the pieces into manageable, testable stuff is something we talked about the principle. Let's show a couple of examples how to do this. But the point I wanted to make is this. Going back to collaboration. If the developers aren't thinking enough about how to please testers needs to have this kind of conversation with the developers of what they need in order to test better or more effectively. So this is where the collaboration hits it. We need to be part of the discussion, part of the design, really, process of how the code is going to be designed in order for our test to be designed to be more effective. Okay, so you got the point. Let's look at some examples here. So a couple of things, and usually developer tests, these are things that are written by developers. I know, big shock. But depending on the skills and level of testing with the developers, they might need some guidance. So what I'm going to show you today are actually developer tests, but all the things that I talked about, seams, code organization, and the examples of bits of tests I'm going to show you, they may think about it themselves, or we, the testers, might be able to help them collaborating together, thinking about the different types of tests that we want to do. For example, input validation. So I showed you the constructor. Where is it? There's my agent, remember, the constructor here at the beginning, checks all kinds of things that the key is okay and so on. So I probably need some kind of input validation. And in my case, that means that I don't need a real model. This is like things that will not even get called, and just make sure that we have an exception or something like that. The scaffolding, the bits of code that we do something in, that the developers write. So this is checking that given a prompt format, it embeds to get the values in the right place. So it gets an endpoint and gets a result. Why does it look like this? Because it doesn't go through loading the prompt. Again, this is something that is done by design. I planned it this way, and I can check that it's embedded correctly, so I don't need to work with the entire prompt. Think about like a real giant prompt, which you're going to embed like lots of stuff in there. It's going to be hard to test, but we think about it in advance. We can create something that is more easily testable. So that's one thing. This test checks that we get a response, simulated response. You see, this is a valid fake key. So we won't fail the construction, but we're not actually making calls. We sort of simulating that this was the response, and we call the format plan with the response to see that things are really in there. And we can check that if something kind of murky happens to return, that our code works better and checks that things are there. Or this one test that sort of like and the entire public method, but with a mock call. So kind of mocking the response here. And so we tell it that when you call the model, really get a mock call with this kind of string. And I'm checking that the public method actually does what I want. And the plan includes whatever I need. So this is the bits of code, the bits of logic that I'm interested in to make sure that they are working. If they are not working, there's no chance of everything working together. Okay, so it's like unit tests before integration tests, same logic. Logic's too loaded word, but you know what I mean. Okay, so that's the scaffolding. Plumbing. Plumbing is the code that wraps around the model, and we want to make sure that it works as well. So for example, this one calls the agent with a mocked model call. It looks so it uses valid fake key, doesn't call the model, but it makes sure that if something happened along the way, like we get an API error, the whole system works in a graceful manner. So get an API error, doesn't crash. But also, I told you that it checks that if the response is too small or empty. Why would that happen? Well, happened to me a lot. If you, for example, specify a small token window, and like I used like a couple of hundreds, and it was too small to create a plan. And when I did that, what happened is that I got an empty response. So if that happens, at least in my code, I want to know that the response was empty. Why would I want to know that? Well, I want to debug the system. This is something like an error situation that happened, and I want to return an error that tells me, well, see, the AI model returned an empty plan. I want to do that. If I don't do that, or I don't collaborate with the developers to do that, I wouldn't know what happened. And I may need to write a lot or read a lot of logs that this would be somewhere in there. Again, this is our pieces of the stability that we need to make sure that are in there. Otherwise, we're going to spend a lot of time digging. I don't like digging. Okay, this is a part of the agent. This is the controller also, right? It's a REST API. I call it want to see how it's working as well. Again, this is developer test, and a couple of them I want to make sure that the bits in there are okay. So the controller, for example, it has some kind of validation for missing data. If I'm not sending the URL, for examples, it will tell me there's a missing required field. I want to test that. Again, these don't go into the model itself. This is a small integration test that I can mock. And again, I built it this way and I designed the test this way, so I wouldn't need a whole model that creates a response that's different every time. So this one checks that if something happened inside, what is the error that I see from the outside, could not generate the plan, and this comes from the response. And this one, for example, checks that the structure that is returned based on a working response is correct. So I'm checking that the JSON is returned as a key called plan, and this is what's going to be in there because I mocked it. So these are the pieces of things that I need to make sure that are in place. If they're not there, what am I doing here? Okay, so yeah, these are the developer tests. Let's move forward. Let's say the developers' tests are working. Excellent. So now we're testing the entire thing with a live engine. So let's talk about Sanity. Sanity checks, smoke tests, whatever your definition is that if these things are not passing, there's not much point in testing further. So we're kind of dropping down the funnel, and we kind of eliminated all kinds of other things. So the developer tests are working. Let's move another thing, another level down. I can do this again. So these tests are with a live agent. You see, this time I'm calling it with a key and a model. This actually goes to the model. And I am just doing a get user ID thing. What kind of things am I testing? So I can test the entire system, how I know how the system works, controller and agent, so I can test the agent itself. I know the call comes from the inside. I can separate this. So this is a full integrated test, but I'm calling the agent rather than the entire thing. We'll talk about that in a second. So like Sanity checks. The plan has the required sections. I specifically asked in the prompt to have these kind of sections: API explanation, happy path, unhappy path, and edge cases. If it's not there, that means that I don't have anything to do with the further testing. It's not hitting any baseline. So I can do that. This one just calls the agent. You can see that. Okay, that's the actual agent thing. What else? Content relevance, right? I hit it with a method with get user ID. I want the terms user and ID to be in there. If they're not in there, probably not good enough. And the third test here is not really a test. You don't have an assert, but could be interesting because this one checks that there's a minimal time that needs to. So I could, instead of printing it, I could put an assert here. I'll show you in a minute where I do put it, but this this whole processing took X milliseconds. And if it takes too long, I want to know about it. If it's not, if it takes too long, this is a failure. And I chose not to do this at the agent level, but I did choose to do this at the controller level. So the controller, this one is actually a test that calls does a post to the generate plan with the method information. This is the body, and it takes the time and it takes the end time. It looks at test timeout, because now we're talking about at least 2 jumps, right? From the test to the controller, last controller, one hop, and then another one at least to the model. So I can start saying, well, the whole thing in terms of experience to the user needs to be like limited. And if we hit that limit, if we go out of this, this is not good enough. So what I'm showing here is it's not just functional stuff. It's not that what it does, we can say that this is not good enough. We're talking about non-functional as well. And we can extend that to other stuff as well. We're not going to do it today. Next time. So these are like sanity checks for the entire agent, but we can do like a bit more than that. So correctness of data. Okay, so hallucinations. So we can define hallucinations in different way, but I asked for a get. Don't give me plans for delete, post, and update. And of course we can. It's not like just checking that the response includes that, but I can do all kinds of things with it. But this is an example of what I want to check. Categorization. So I asked for explanation and happy path and unhappy path and stuff like that. Edge cases, right? So I asked for them in this order. It matters to me because this is part of the quality benchmark that I'm looking for. So I can check that, first of all, they're all there, and then that unhappy index, the unhappy part, comes after the happy path. So happy comes first, unhappy comes second. This is what it actually means here. And if not, this is not good enough. Or I want to make sure that there's somewhere an invalid case in there. I want it to be at least after the unhappy. Can assume that it is included there. It's not completely true in this case, but these are terms of quality that I put in there, and I want to make sure that if it's not like that, this is not going the way I want to. I would stop things. And these are like a parameterized test that checks that the different post with different post or delete different APIs return something that at least have these things. So if I do a post with the login, I want a plan that includes login and user. Or if I delete a product, I want delete a product in there. And these are what we called last time diversity checks. We can expand more and more about what we're looking for to be in there. And we can write tests for that. Final thing that I want to show you is something that I'm going to show. I'm not sure if it's working. Let's see. Let's give it a run. Prompt injection. What happens if somebody enters in the prompt somehow, ignore all previous instructions like you expect it to have, and do something? Like tell me a joke. So I want to make sure that if somebody is trying to inject a joke in there, you can see that it's running. At least I don't want to get, oh, you see, got a problem. Oh, it's because of the different stuff. Didn't get the product in there. The joke is in there though. The joke is not in there, but product is not in there also. So this kind of things tells you, well, it's not that it's not doing its job, because this one isn't. It's doing its job in terms of other non-functional stuff, in terms of security. So we need to think about these things as well. So these are, again, is this a sanity test? It depends of like if this doesn't pass, does this mean that the whole system doesn't work, doesn't require? You need to set your own benchmark. But we need to think about these things as well. Okay, so these are the sanity stuff. Let's talk about the insanity stuff. So we're dropping out down the funnel. We passed our sanity things. Everything we define as must work, works. And now we get a bunch of answers and we need to say, well, are they good or not? Problem is that here we need to do this manually, like Mr. Bean here. We need a way to do this. In my case, is the plan that I got is good? And this can change, and I'll walk you through the scenario because I prepared one. This is like I get user ID. If I run this, it calls, let me run this. This is not even a test, it's just a call to the agent, and it prints out the plan that it got. See it here, just to see that it's working. And I get all kinds of cases here. And every time I will get something else, right? So in order for the demo, I will work with one thing. So this is a reply I get. So you can see this is text oriented, right? It's like I asked for Markdown, and it contains many things, and I need to tell you, my bosses, if this is a good plan or not for get user rating. So how do I do that? Well, you know how to do this because testers know how to do this. You kind of inspect the result and say, well, what are the things that are working? But this time, because things are a bit fuzzy, we need something more formal to help us. Again, like the question I asked you in the beginning, if I'm looking at it and say, oh, that looks okay, it may look okay to me, but for you, maybe it's not that okay. So kind of need some kind of baseline that tells us, well, this is okay. Okay, so how do I do that? Let's see. I'll create a golden data set. So what is a golden data set? I need some kind of thing like this that tells me, well, what am I looking at? And my golden data set, remember, this is like an optimal thing. If I get something that looks like this is okay. So it doesn't have to look like it. It doesn't have to match exactly, because this is like a manual thing. I'm looking at it, and it sort of says endpoint retrieves a single user profile information. It's okay. Maybe not in these words. but we can decide if it's exact or not exact. Usually it's not about exact, it's about having the concepts in there. Because in order to continue, this is good enough. So I want an explanation for my method to have something like this, and the happy path to have retrieve an existing user with a valid ID, and I can decide whether it's just one or at least one. But I wanted to have at least retrieve existing with valid ID because this is a get user by ID, right? And unhappy path is request a user with a non-existent ID and request a user with an invalid ID. And edge cases request a user with the lowest possible valid ID. Except this is like my optimal dataset. If it has this, everything works. If it's not, it may not be crucial, but I need a way to rank it. So let's rank it. How do I do that? Well, I take my result and create a quality score. How do I do that? Well, this is when I ran it. This is my endpoint, and now I'm giving it scores manually. Remember, this is not an automated way. We can do automation once we figure out if this is okay or not. So let's look at it. Explanation, correct? The explanation is okay. Happy path, good. Unhappy path, good. Edge cases, let's look at what I said. In the golden dataset, I said request a user with the lowest possible valid ID. And I'm guessing that this has to be there, otherwise it's not that good. Let's look at the result. So I'm going back to edge cases, and I'm checking what it gave me. And it gives me a very large user ID. It gives me a user ID containing leading zeros. It gives me concurrent requests. But I expected it to have something with lowest possible ID. So didn't get that. So when I'm scoring that, when I'm scoring that, I will give this a mid. And that means this is like per section. I did also like get it a couple of columns, like an overall thing. Explanation quality, does it give me good explanation for the plan? Yes. Test case relevance? Yes. Functional coverage? I wanted the one with the edge case. It didn't give me, so I give it a lower thing. And I can do some kind of calculation. So what I did here, very simple. Out of the all 9 points that I could give it, it gets an 8. Is 8 good enough? Maybe. Let's say it is. But then I noticed something. Let's look at the result again. I want to scroll up to the happy path here because this one has something interesting. You see the happy path, this kind of case, contains the user's data, ID, username, email. Well, this is like private information. I don't like private information in test plans that I give other people. This is going to be all kinds of bad. So I got this, and I got this yesterday, right? And I'm looking at it now. And I said, well, yesterday I thought it was a good response. Today, it's not a very good response because it exposes too much data. So I need to sort of reset my expectations of what is good. So I improve my golden dataset. I'm adding this, verify the response doesn't contain sensitive non-public user data. If the response that I get doesn't include it, it will get a higher score, which exactly what I want. So same response, new score. Let's look at the algorithm now. So explanation is still correct. Happy path, same response, now gets a lower score because it doesn't answer the new criteria. Unhappy remains the same thing, and edge cases remains the same thing. I also added a column for risk and security coverage because this is the part that interests me. The change because the response didn't change. I changed. My ideas of quality has changed. So I need my quality score to specify that. So now I've got, like in the same algorithm that I had before, I have 12 points that I can collect. But based on the marks that I'm giving it now, it will get a 9 because it's not giving a risk or security coverage very good. Now, is 9 out of 12 good? I need to decide, first of all, what is a good thing. And maybe this is very important for me. So this should have a larger weight in the calculation. So all this, all the process that I went through with you in the last couple of minutes, is like exploration of how we perceive quality. And this is an iterative process. And we need to go through it. And like, this is a very simple case, but already you see that how things can change. Again, not in the response, it's how we perceive things. Now, what would I do if this happens? Well, I run it, get a low score, I need to fix it. There are different ways to fix it. I can change the prompt to make sure that this doesn't happen. Or I can ask the logic in my code, in the agent, to clean it up if something like that returns, to look for this kind of stuff and kind of mask it. But what I did is basically specify the criteria of quality. From now on, if 9 is not good enough, the developers or somebody else will need to fix that. Now, can this be automated? Well, if you got an algorithm, you can automate it. So I took this different in a way. So let me show you. Let's just get the user ID. And this one is with weights. So happy path should have an existing and valid. And if it's not there, if it's there, it gets a high mark. So 3 gets high mark. Unhappy, non-existent. Edge cases, large, 0, concurrent, gets 1. Why? Because this is how I decided. And this runs it with the first set of initial golden concepts. Let's run it because I know when I ran it yesterday, it didn't work. Why? Because I gave it, it has to be 8 or enough, 8 or above. Not sure what will happen right now. Let's see. That's the, yes, got 7. Why? The unhappy didn't have the things that I worked with. I hoped will be there. So if this doesn't have the initial quality bar, imagine what will happen if it will, remember the prompt doesn't have anything about security yet because I haven't fixed it. This will be a very low mark. So these two are not going to pass. And we need to tweak it as much as we can. Yeah. See how it got, yeah, 7 out of 15. We need to tweak it in order to meet the bars that we've raised. There was a question, does the prompt explaining the model how to do its best to exam? Do we have directions to include a happy path? So the prompt does include to have a happy path API explanation, the sections in the plan. It does not have anything to do with the new stuff that we discovered, like security or emails or stuff like that. The next step would be to fix that. Okay, want to show you something that is down the funnel, but I'm not going to go deep dive into that today, which is everything's all good. We passed the sanity. We passed our golden data sets. Everything's working, but still, we got 2 plans. One that looks like this with a valid user ID, check specific field, and invalid user ID not found. And we got another with a valid but minimal user data and invalid user ID non-numeric. And you ask yourself, well, how would that happen? Well, the answer, first of all, it's non-deterministic, right? It will always do something. But the test I did was playing with temperature. So temperature is a parameter that we pass to the model. And if it's a low number, you get something that you'd expect to get. Remember, when we're talking about models, they're predictive, like they're creating some kind of prediction. But with higher temperature, we kind of give them ways to be more creative. So we can expect to have different kind of things. So the same prompt with the embedded data, just playing with the temperature gets us different results. Now, both of them are okay. I did something very simple in terms of sanity. here. Both have to have happy path and happy path. Of course, I can run everything with them, but let's say they both ran through that funnel. Everything went through the filter and both are good. Which is better? I won't answer that now. I want to go back to my slides now. So we went through like the planning and design and checking our logic, and then the sanity check, which means that without this, there's not much point in continuing. And then the manual quality check, and then we even saw the automation of that. But obviously, this doesn't solve the long term. This is like a one-shot thing, and we're not testing over a long shot. So we need something that is working, like talking about the framework here. This needs to work over the long haul. It looks like this. So after we have this, we're going to iterate through tweaking and analyzing, and then doing the manual check again, and some of them automating it, put this into the regression suite that we have, and continue to do that. And while we're doing that, we're going to talk about reliability. Maybe we have some kind of drift in our responses over time. There is such a thing. Model change beneath our feet without our knowledge, like ChatGPT 5, where it replaced ChatGPT 4 and kind of chooses your model for you. Now what do you do? So this thing needs to work like all the time, and it's not like a one shot that you build and it works okay. Not that any product did that, but this is the same thinking that we have for regular products without AI. This is kind of raises the bar for them because the challenges are different. So on that, we're going to talk in the next webinar. But before we do that, I have another poll for you before we turn into questions. This is a simpler question because it has just two options. Where do you see yourself today in terms of this process? The one that thinks about the whole strategic part of the things, or the one in the trenches that tries to automate stuff and so on? From our crowd here, we got a 60-40 thing in terms of towards the engineering part. Why am I asking that? Well, a couple of things. First of all, next webinar. Next webinar is going to be on December 3rd, so it's a bit more than a month. And it's charting the course of air quality for the long haul. This is like the third part of the series, which will take a more strategic view of how do we do this and how do we take this framework over the long haul. So I mentioned a couple of things, some challenges that we have on our way. I will talk about them. So that's one thing. Working on two different workshops. One for the strategists of you, the people who manage stuff, people who look and methodically of how to test stuff. And the second one is for the people in the trenches, more technical stuff. And I'm interested in your interest, what you're interested in. And this is why I ask you. So there are wait lists. You can scan the QR codes, go there, and if you're interested, put your name there. No commitment, but I'm engaging interest in what is more attractive to people. Go there. The same links appear here, and let's talk questions. So put them in the chat box or the Q&A. There was one that I missed. Who decides what to include in the golden data set? The testers, the ones that say, well, remember in the before times, when we wanted to test a calculator and we wanted to see if 2 plus 3 equals 5, how would we know that? Well, we need to be expert in some way. Okay, either we'll have a reference or we'll get a high level mathematician who can do these kind of calculations. And we kind of ask them, well, give us examples of what makes a good calculator. This is the same methodology. We need to be expert about the system. Only this time, the system is kind of shaky. So we need to tell ourselves or teach our team or decide between ourselves what makes a good system, what, in our case, what makes a good response, or even better, what makes a bad response, so we can say reject the problem. So this is the same testing skills that we had only before, it was kind of, we look at the results and say, this is very clear if it's working or not. We need to get to the same point where we can decide when it's either clear that it's working or clear that it's not working in order to continue that. And this is like sort of an upgrade to our skills. And we need to work on that in order for it to work. Any other questions? Okay. So I want to thank you for coming today. I hope this was enriching to your lives. And if you have some questions, you know where to find me. If you're interested in the next webinar, remember it's going to be on December 3rd. You can go and register right now. And if you're interested in one of the workshops that I'm developing for the strategists or the engineers, go write yourself up on the wait lists. Until next time, thank you very much for coming today and see you next time.